Okay, so we're going to pick up just where we left off. This will be a really short video with derivative rules. So there are two rules that you need to also get down, which is the constant multiple rule. So if u is a differentiable function, all right, sorry about that. If u is a differentiable function and c is a constant, then what this says is that the derivative of this function is just that constant times the derivative. And so the constant, really you're just multiplying it with whatever the derivative is, which is what we kind of saw with the power rules when we had a 3 out in front. We took the derivative of the x to the third and multiplied it by 3. And lastly, so the sum and difference rule, which makes this really nice. If u and v are two functions, so they've got, maybe this is x to the third and x to the fourth, the derivative of the two functions is just the derivative of the first plus or minus the derivative of the second, depending on whether it was plus in between these two originals or minus in between. And this is true as long as both derivatives to the function exist. So let's take a moment to apply this to a couple of these functions. Okay, so this is our first example. If I want to take the derivative of this function, just in general, so I'm going to take, because these are all separated by plus and minuses, I'm going to apply the sum and difference rule. So the sum and difference rule means that I just take the derivative of each and I keep the same sign that's in between. So in this case, if I were to take the derivative of 3x to the fourth, well, 3x to the fourth, I'm going to apply the power rule. So that means that I'm taking 3 times, move my exponent down, 4x to the power, I lose 1, of 3. So this is going to simplify down to 12x to the third power. Minus, and now I'm going to look at my next one, 2x to the third. I'm going to keep my constant out in front 2 times, and now I'm going to apply the power rule. The 3 comes down, x to the 3 goes down to a 2. This is going to simplify to a 6x to the power of 2. Plus, now I've got my 6x squared, 6x2. Well, my number, my coefficient stays out in the front 6 times x to the power of 2. My 2 is going to come down. And then x goes down, my exponent goes down to a 1. So this will simplify down to a 12x. Then I've got my next one is 7x. So I've got a minus. The derivative of 7x, well, I keep my multiple out to the front 7 times. Then I've got an x to the 1 here. So this becomes x to the 0. Remember that anything to the 0 power is just equal to 1. So this is like 7 times 1, which just leaves me with 7. And my last derivative, when I take the derivative of a constant, remember going back to this rule, the derivative of any constant function or any number is just 0. So since it does not have an x, this derivative just goes to 0. This will be my f prime of x. Solve part B and C to this example. What is the derivative of these two functions? Okay, to go over this last one, just because I have a feeling there may be some issues with it, before you take the derivative, I would FOIL this out for right now. Eventually we'll talk about how to take the derivative of this function without FOILing. But to take f prime of x, I would take 3x squared minus 2 times 3x squared minus 2 so that it's in a form that I recognize. So really I'm taking the derivative of a 9x to the 4th minus 9 times, or 3 times 2 is going to be 6. I'll have 2 of those, so minus a 12x squared plus 4. And I'm taking the derivative of this function. I'm really just taking the derivative of this function rather than of this one. And this one is something that you know how to do. So go ahead and make any corrections. What's the derivative of this function going to be? Next set of problems, we're going to find the equation of the tangent line at the indicated point. So I'm going to start off with this first one, f of x equals 1/2 x to the power of 3 plus 2x at x equals 1. When I'm finding the tangent line equation, before I start, I want to find my y value when x equals 1, just because that'll be helpful later. So I'm going to start off by finding f of 1, which is just going to be 1/2 times 1 to the 3rd power plus 2 times 1, or 1/2 plus 2. F of 1 will be 5/2. So my point that I'm looking at for my tangent line is the point 1, 5/2. This will be helpful later. Once I've gotten that point, I'm then going to find the slope of the tangent line. Which is my derivative at that point. So the slope of my tangent line is the derivative at that point. So I'm going to take the derivative of the function f of x equals 1/2 x to the power of 3 plus 2x. So when I take f prime of x, I'm going to leave any multipliers out. So 1/2 times the derivative of x to the 3rd is going to be 3x squared plus my multiplier 2 times the derivative of x is just x to the 0. So this will become f prime of x is equal to 3 times 1/2 is just going to be 3/2 x to the power of 2 plus 2 times x to the 0. Remember, that's just going to be 1. So 2 times 1 is going to leave me with 2. So now I'm finding the slope of the tangent line. I've got the derivative. I've got to plug in my x value of 1. So now I'm finding f prime of 1. So this is going to be 3/2 times 1 plus 2. This will be equal to 3/2 plus 2. Remember, 2 is like 4/2 as a fraction. So 3 plus 4 is going to give me 7/2 is my f prime of 1. This is going to be my slope. And I've got a point. I'm going to put my tangent line equation into point slope form. So that's y minus y1 is equal to the slope times x minus x1. That's going to make it go really quickly. So y minus my y value is 5/2 is equal to the slope 7/2 times x minus my x1 is just 1. And that'll be the equation of my tangent line. Go ahead and do the same for these three. We're going to talk about example 3 in class on Monday. That'll be it for the videos. Make sure you watch the other two that are up.